Well, hello everyone. In this lesson, we will be discussing quadratic functions. A quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are constants and a is not equal to 0. In general, when a is greater than 0, the parabola opens upwards, and when a is less than 0, the parabola opens downwards. The vertical line through the vertex of the parabola is called an axis of symmetry. The maximum value of the function is the function value when a is less than 0, and the minimum value is the function value at the vertex when a is greater than 0. Now let us look at some graphs of quadratic functions. For example, if f of x is equal to 3x squared minus 2, this parabola opens upwards. Describing it, we can look at the graph of the parent function, x squared. Notice is 3 times x squared, so that means that the graph of x squared was vertically stretched by 3, and then for minus 2 means that it was shifted down 2 units. The vertex is at 0, negative 2. And that means that the minimum value will be at negative 2. In our quadratic function formula, 3x squared minus 2, a was equal to 3, b was 0, and c was negative 2. The x-intercepts of this graph can be seen right here. And these are negative radical 2/3 and positive radical 2/3. X-intercepts are also called zeros or roots of the function. Now there is a theorem for locating the vertex of a parabola. This theorem says that the vertex of a parabola of the form ax squared plus bx plus c has an x value at the vertex of negative b over 2a. So at the vertex, x equals negative b over 2a. And then we plug this negative b over 2a into the function. F of x will be f of negative b over 2a. Therefore, the vertex coordinates will be negative b over 2a. Vertex coordinates will be negative b over 2a, comma, f of negative b over 2a. Right? And now, if we have numerical values for b and 2a, then we will end up with negative values for the vertex. Now let's look at an example. An example of this as determine the vertex of the quadratic function y is equal to 16x squared minus 8x plus 21. So here we want to identify our a. So a equals 16. B would be negative 8. So b equals negative 8. C is 21, but we will not use C in our formula because we want to find the vertex. All we need is A and B. Now remember that the vertex coordinates were negative b over 2a for x value, and f of negative b over 2a, that was your function value, y value. Now let us find the x. X is negative b over 2a, which would be negative of negative 8 over 2 times 16. Negative of negative 8 over 2 times 16. And so that would be negative of negative 8, which is positive 8 over 2 times 16, which is 32. Simplifies to give 1/4. The f of x would be f of 1/4, which will become 16 of 1/4 squared. 16 times 1/4 squared minus 8 times 1/4, 8 times 1/4 plus 21, and that will give us 20. So at the vertex then, at the vertex will be the coordinates 1/4 and 20. 1/4 comma 20, and that is the vertex of the function 16x squared minus 8x plus 21. Now let us look at another equation for finding another quadratic equation, another type. This type of equation includes the values of the vertex, right? Some books call it the vertex form. This form is y is equal to a times x minus h squared plus k, where a is not equal to 0. This has a vertex hk and a vertical axis. Okay, has a vertical axis and hk as your vertex. Again, if the parabola opens up, a is greater than 0, and it opens down, a is less than 0. Now, if f of x is equal to ax squared plus bx plus c, then by completing the square, we can change the form to f of x is equal to a x minus h quantity squared plus k. Now, if we can remember, completing the square, if we have something like ax squared plus bx plus c, we complete the square for ax squared plus bx by adding b over 2 all squared and also subtracting b over 2 all squared. So adding and subtracting will effectively remain the same, but the way that it will look will be different, because after you complete the square by adding b over 2 squared to this part, and then from the c you subtract b over 2 squared, then we will get the form a x minus h all squared plus k. Right? The numbers will have different numbers, and then we'll identify them as h and k. Now let's look at a quick example. If we have f of x is equal to x squared minus 10x plus 29, f of x is equal to 10x. So we have the minus 10x, so that'd be x squared minus 10x plus 29, right? This is our a, b, and c. So a will be equal to 1, b equals negative 10, and c is equal to 29. What we want to do is that we want to write the a and the b together. So that x squared minus 10x, and then to that we want to add b over 2 squared. Add b over 2 squared, but b is negative 10, so that would be negative 10 over 2 squared. And then write the c afterwards, so it would be 29. And then from that c we will subtract negative 10 over 2 squared. So we're adding and subtracting the same number. This part, x squared minus 10x plus negative 10 over 2 squared, which would be x squared minus 10x plus 25. What we will do, we will write this as a complete square, which is this x, and then 10 over 2, which is negative 5, so minus 5 squared, and this is another way of expressing this part, and then plus 29 minus negative 10 over 2 squared, which is 25, so that will be 29 minus 25, which is plus 4. So in this form, ax minus h squared plus k, your answer will be f of x equals x minus 5 squared plus 4. And that's your final answer. Now for the next problem, g of x equals 3x squared minus 13x plus 5. We do a similar thing. But before we do that, we will factor out our 3 so that in completing the square, we only have the x squared. So we'll factor out the 3. So we have x squared minus 13 over 3x. Then to that, we're going to do a plus 5. Now, use your 13 over 3 as your b. So then your b would be equal to negative 13 over 3. And then we're going to add and subtract that amount to what is in the parentheses here. So that's x squared minus 13 over 3. And then plus 13 over 3 divided by 2. It's going to be 13 over 6. So that they get 13 over 6 squared. Then plus 5. And then whatever we added to this section, or the left side, let's think of it that way, we will subtract from the 5. So that would be negative 13 over 6 squared. But notice we had this negative 13 over 6 squared multiplied by 3. So we have to also multiply it by 3 there. So finally, what we will keep on doing is that we will continue working through all of this. And when we finish working through all of this, what we will end up finally getting is 3 times parentheses x minus 13 over 6, which is from the completed square here, all squared. And then this part will simplify to minus 109 over 12. And so that is your new g of x expressed in the form ax minus h all squared plus k. And that is our final answer. Now let us look at some more quadratic equations. In this case, we're talking about the quadratic formula, and that is used to find x-intercepts or roots of a quadratic function in the form ax squared plus bx plus c. Now let's look at an example. In an example, we're asked to find the roots of a quadratic equation 5x squared plus 9x plus 2 equals 0. So we identify our a, b, and c, where a equals 5, b equals 9, c equals 2. Plug those values into the quadratic formula. X equals negative b plus or minus b squared minus 4ac over 2a. Put in those values and simplify all the way down. We finally end up with negative 9 plus or minus radical 41 over 10. So we have two values for x, two values for your x-intercepts. One which is x equals negative 9 plus root 41 over 10, and the other being x equals negative 9 minus root 41 over 10. Now let's talk about something called the discriminant. Now the discriminant is the radical expression, the expression under the radical in our quadratic formula. That is b squared minus 4ac. And it's important in that if b squared minus 4ac is greater than 0, it tells us that there are two real roots. If b squared minus 4ac equals 0, it tells us that there are one real root, and b squared minus 4ac is less than 0, gives us no real roots. There are three examples here By plugging in these numbers, we find